is the branch of physical chemistry. Chemical kinetics. Kinetics is the branch of physical chemistry. Is the branch of physical chemistry. Chemical kinetics is the branch of physical chemistry which deals with rate of reaction. Rate of reaction. That means chemical kinetics explain how fastly the reaction takes place. What are the factors influence on the rate of reaction? These are the topics we learn in this chapter. Now in the introduction part, first we try to understand what is rate of reaction. Okay, rate of reaction. Rate of reaction. Simple definition about rate of reaction. The rate of reaction can be defined as the change in the molar concentration in terms of the reactants or products. The change in the molar concentration. Change in the molar concentration. Molar concentration. The change in the molar concentration terms of reactants or products per unit time. Once again I repeat, the change in the molar concentration in terms of reactants or product per unit time is called rate of reaction. Rate of reaction. Okay, you know very well, in any reaction, the initial substance participate in the reaction is called reactants. Suppose an hypothetical reaction you can take. Hypothetical reaction. For example, R gives rise to P. Here R means what? Reactants, because it is initial substance participate in reaction are called reactants. Final new substance formed during the reaction is called products. Okay, na? The reactants are converted into product. The process what we call means chemical reaction. Clear? Now see, in any chemical reaction, the initial state of reaction, the concentration of reactants maximum. Concentration of reactants maximum takes place here. Concentration of products at the beginning 0. No products are present at the beginning. Now see, coming to the with respect to reaction proceed or with respect to time proceed, the concentration of reactants, concentration of reactants gradually decreased. Concentration of reactants gradually decreased, as well as concentration of products. Concentration of products gradually increased. Concentration of products increased. This is happen in the any chemical reaction. So concentration of reactant decreases as well as concentration of product increases with respect to time proceed. Clear? Okay. Now see, decrease in concentration per unit time, what we call rate of reaction. Similarly, increase in concentration of product, what we call, that is also rate of reaction. So rate of reaction we can define in terms of decrease in concentration of reactants per unit time as well as increase in concentration of product per unit time. So rate of reaction is equal to decrease in concentration, short form I written, concentration of reactant per unit time, time t or unit time t. Okay na, simply. Similarly, it is also equal to increase in concentration of product per unit time. So this is about what, a relation between rate of reaction and concentration of reactants and concentration of products. Clear? I hope you all understand, right? Now suppose the same equation we can express in mathematical way. The rate of reaction R is equal to change in concentration of reactant, that is change in concentration of reactant, suppose dou R by change in a small time interval dou T is equal to increase in concentration. Here concentration of reactant decrease, no, so that we can write here minus sign. Similarly, concentration products increase, right, so that plus dou concentration of product by change in time dou T. You can express the rate of reaction simply R equal to minus dou R by dou T is equal to plus dou P by dou T. Okay, right. Now see, this equation you may express even R equal to the change in concentration delta R by delta T is equal to here delta product concentration of product P by delta T. But according to the given statement, the concentration of reactants decreases, so that in front of concentration term of reactant we can use minus sign. Concentration of product increases, so that here we can use what, positive sign. So rate of reaction R is equal to minus delta molar concentration of R by change in time T dt or delta T. It is also equal to increase in concentration of product, so plus delta change in molar concentration of P by delta T. This is the mathematical expression for rate of reaction. Clear, my dears? Right. Okay, I hope you all understand, right? Rate of reaction. The next now coming to the rate of reaction we express for a given reaction. How to draw the rate of reaction for a given equation. See, earlier we discussed, right, the last statement, rate of reaction R is equal to rate of reaction R is equal to change in molar concentration terms of reactant by change in time. So molar concentration terms change means what? Decreases. So that the decrease in molar concentration term we represent with minus delta T R by delta T delta R by delta T is equal to increasing molar concentration terms of product plus delta P by delta T. Okay. Now let us take an equation. Suppose an equation is given. That equation is PCl5 gives rise to PCl3 plus Cl2. It is simply decomposition of phosphorus pentachloride into phosphorus trichloride and chlorine, right? For this reaction I want to write rate of reaction. The rate of reaction R equal to, here concentration of product means what? PCl3 plus Cl2. Concentration of reactants means what? PCl5. So that according to the above expression, minus delta change in concentration of PCl5, that is PCl5 with respect to change in time dt is equal to plus change in molar concentration term of PCl3 delta PCl3 by delta T. It is also equal to what? The change in concentration terms of molar concentration term of what? Chlorine. So plus delta Cl2 by delta T. This is what? Rate expression for a given reaction. Clear? Here concentration of PCl3 and Cl2, those are products, right? So that in front of those concentration term, what sign we used means positive sign. That positive sign indicates that increase in concentration of product with respect to time t, change in time t. Similarly, here negative sign we used in front of concentration terms of reactant. The negative sign indicates that what? The decrease in concentration with respect to time t. Clear, my dears? Now coming to the, based on the rate of reaction or the speed of the reaction, the reactions are categorized into three types: very fast reaction, moderate reaction and very slow reaction. So based on the rate of reaction, the types of reactions are three types. Now find types of, next concept is types of reactions. Types of reactions. Types of reaction. First one, very fast reaction. Very fast reactions. Very fast reaction means these are also called instantaneous reactions. That means this reaction carried out within fraction of second. The reaction completed in fraction of seconds. Fraction of seconds are called very fast reaction. Very fast reactions. So this very fast reaction also called instantaneous reactions. These are also called instantaneous reaction. Very fast reaction, also called instantaneous reaction. So these reactions carried out in less than 10 power minus 16 second. These reaction carried out or carried out in less than 10 power minus 16 seconds. We can't imagine that speed. So in the fraction of seconds this reaction is completed. What kind of reactions are example for very fast reaction? See, for example, ionic reactions. Ionic reactions are very fast reaction. Ionic reactions are example for very fast reaction. Okay, next, precipitate reaction. Precipitate reactions. These are also example for what? Very fast reaction. For example, barium chloride BaCl2 treated with sulfuric acid gives rise to BaSO4 plus 2HCl. In this reaction, here barium sulfate is the precipitate or double displacement reaction. Even ions are involved here. Similarly, BaCl2 Na2SO4. Then what is the reaction here? BaSO4, white color precipitate is formed, and Na2SO4 means what? 2NaCl we got it here. 2NaCl. Like that, here precipitate reactions. Even AgCl on treated with sodium nitrate NaNO3, it produce AgNO3 plus NaCl. Here AgNO3 is the white color precipitate. Like that, precipitate reactions, ionic reactions, even neutralization reactions, these are very fast reactions. Clear my dears? Next, now even combustion reaction. Okay, na? These all are very fast reactions. Now coming to the slow reactions. Slow reaction are moderate reactions. Second type of reaction is what? Slow reaction or moderate reactions. So slow reaction or moderate reaction. Slow reaction or moderate reaction. Slow reactions are moderate reactions. Slow reactions are moderate reactions. That means the reaction which is carried out in few minutes or few hours. The reaction completed. The reaction completed within few minutes or few hours. Few minutes or few hours. Are called what? Moderate reactions. Moderate reaction. The reaction completed within few minutes or few hours are called moderate reactions. Okay na? Moderate reaction. For moderate reaction, example, hydrolysis of ethyl acetate, hydrolysis of ester, simply hydrolysis of ester is an example for moderate reaction. First example, hydrolysis of ester, hydrolysis of ester, hydrolysis of ester. Hydrolysis means what, amma? Breaking of substance in the presence of water, that is hydrolysis. Hydrolysis of ester is an example for moderate reaction. Here see, you know the ester, simply CH3 COO C2H5 COO C2H5 on reaction with what? Water, because it is an hydrolysis, water to produce CH3 COOH plus C2H5OH. Okay na? CH3 COO C2H5, this compound name is ethyl acetate. On hydrolysis it gives acetic acid and ethyl alcohol. This reaction is example for what? Slow reaction or moderate reaction. Slow reaction or moderate reaction. Now coming to hydrolysis of sucrose. Here hydrolysis of sucrose also example for what? Moderate reaction. Hydrolysis of sucrose. Hydrolysis of sucrose is also example for moderate reaction. Hydrolysis of sucrose is also example for what? Moderate reaction. For that reaction, suppose I want to write the equation C12H22O11 on hydrolysis. It decomposed into C6H12O6 plus C6H12O6. That means sucrose on hydrolysis, it gives what? Glucose. One of the compound is glucose, another compound is what? Fructose. Glucose and fructose both are monomers. Monomers means it is simplest unit of sugar, and both are having same molecular formula, but functional groups are different. Glucose is a aldehyde functional group, fructose is having ketone functional group. Glucose is example aldose, fructose is example for ketose. Okay na? Now this hydrolysis of sucrose also example for what? Moderate reaction. Similarly, decomposition of ammonium nitrate. Decomposition of ammonium nitrate it is also example for moderate reaction. Here decomposition of ammonium nitrate means, suppose NH4 NO2 on heating it decomposed into H2O plus N2. This reaction is also example for moderate reaction. Similarly, decomposition of hydrogen peroxide. It is also example for moderate. Decomposition of hydrogen peroxide H2O2. It is also example for moderate reaction. This H2O2 on decomposition it gives which product means H2O water plus half O2. Okay, na? Half O2. This reaction is also example for what? Moderate reaction. Now coming to the last and final type, that is very slow reaction. Last and final type is what? Very slow reaction or very slow reaction. Very slow reactions. So very slow reaction, the reaction which is carried out within few days or few months, the reaction completed in few months or few weeks or few days, few years, few days are called very slow reaction. Very slow reaction. Clear, my dears? Very slow reaction. Best example, rusting of iron. Rusting of iron. It takes a few months or few years or few weeks or few days. Okay, na? In rusting of iron, simply what happened? The iron react with water, moisture, and it produces what? Hydrated ferric oxide, Fe2O3 dot XH2O. This is called rust formula, hydrated ferric oxide. Hydrated ferric oxide. Clear, my dears? So these all are a fast reaction, slow reaction, moderate reaction. The rate of reaction we measured based on what? The time taken for completion of a reaction. I hope you all understand, right? Thank you. Okay, my dears, now we are going to discussing about the difference between average rate and instantaneous rate. Now first we discussing about average rate. Average rate of reaction. Average rate of reaction means simply first point, the rate we measure for period of time. The rate we measured for period of time. Period of time. The rate we measured for period of time, or simply long time interval. That is called average rate. Average rate, it is denoted by delta sign. If you rate expression delta sign used means that is indicates that what? Average rate. For a given reaction, the rate of reaction, for example, reactants convert into products P. For this reaction, average rate RAV is equal to decrease in molar concentration terms of reactant delta R with respect to change delta T. That means what? It is initial concentration of reactants minus final concentration of reactants minus initial concentration of reactants. Okay, now similarly it is also equal to what? Plus increased concentration of product by change in time delta t. Okay na? Right. Now in general way RAV is equal to change in concentration of X with respect to change in time t. This is called average rate of reaction. Average rate of reaction. For that average rate of reaction, now I want to explain graphical representation. For example, the graph with respect to reactants. Here the graph with respect to reactant. See the concentration of reactant gradually decrease, so that rate of reaction also gradually decreases. Initial concentration of reactants are taken as x1 here, x1 at a time t1, at a time t1, the initial concentration of reactant x1 at a time t1. Now after certain time the concentration of reactant x decreased. The decrease in concentration of reactant at time t2 are taken as x2. Now see these 2 points join and draw a line, then what we got means a rectangular hyperbola we got it. This indicates that what? Gradually decrease in rate of reaction with respect to decrease in what? Concentration of reactants. So rate of reaction R decreases with respect to decrease in concentration of reactants. Concentration of reactant. Clear? Now suppose for this reaction I want to express average rate RAV. RAV is equal to change in concentration of reactant. Change means here decreased, minus delta R by change in time delta t. It is equal to, as per given graph, x2 minus x1 by t2 minus t1. T2 minus t1. This is the expression for what? Average rate. Now coming to average rate in terms of products. Suppose I want to express the average rate in terms of product for the same reaction. Then the graph obtained like this. The concentration of product gradually increased, right? So that initial concentration is less, final concentration is more. So that I taken at concentration x 1 at t time, the time t1, initial concentration. After certain time the concentration increased up to x2, the concentration of products x2 at a time t2. Now see these two line join means what we got it? A graph obtained like this, gradually increased. Okay na? That the positive slope of graph indicates what? The rate of reaction increases with respect to increase in concentration of products. Concentration of product. Clear? Now the average rate of reactants, the average rate of reaction of a product RAV is equal to delta P by delta T. Here delta T I expressed x2 minus x1, it is change in concentration of product by t2 minus t1. It is a change in the time t. Okay, now here the slope we got it, positive slope we got it here. Here positive slope we got it. Okay, or increase in the curve increase in, so that indicates what? Positive slope. Okay, my dears. Right. Now I want to express instantaneous rate. Instantaneous rate with respect to reactants as well as product. How to measure instantaneous rate? Clear? Right. Now see instantaneous rate. Instantaneous rate. INSTANTANEOUS instantaneous rate of reaction. Here instantaneous rate of reaction means the rate we measure for a point of time. The rate of reaction we measured or we calculated, measure for a point of time or small time interval is called instantaneous rate. Instantaneous rate, right? Now it is denoted by dou sign. It is denoted by dou, the sign dou. Here instantaneous rate of reaction RINS for a given reaction R equal to P, then RINS is equal to minus dou change in concentration term of reactant R by dou T is equal to plus dou change in concentration term of product P by dou T. This is the rate expression for instantaneous reaction, or simply RINS is equal to dou X by dou T is general way of representation. Okay, na? Now coming to the graphical representation. Suppose I want to draw the graph in terms of reactant. I want to draw first. For reactant, the concentration gradually decreases with respect to increase in time or reaction proceed. And your initial concentration x1, final concentration x2. x1 at what? Concentration of reactant at time t1. x1 at time t1. Here concentration of reactants x2 at time t2, right? So this is the change in time delta. Here t1 t2, the difference is equal to delta t. The change in time is nothing but delta t. Change in concentration, these two difference what we measure, that is called delta x. Now here draw a line to join this point, means what we got it, the rectangular hyperbola we got it. Now see, very important point. Suppose I draw a line, a straight line, a tangent on here, where the point, the particular point, the line touch the graph. I want to measure a rate of reaction, a particular point here. particular point, then the T is said to be instantaneous rate, or INS is equal to change in concentration of reactant dou R by dou T, that equal to x2 minus x1 by t2 minus t1. Here slope of the graph, slope is equal to negative, we got it. Slope equal to negative, we got it. Suppose the same graph I want to express in terms of product, then the concentration of product, the rate of reaction increases with respect to increase in concentration of product. Then the x1 is the concentration of reactant at time t1. x1 is the concentration at time t1. x2 is the concentration of product at time t2. Now see, these 2 points we join means we got it a line which is increased positive slope like this. It is like rectangular parabola, we got it. Now here draw a straight line, a tangent. Suppose I want to measure the rate of reaction here, then draw a tangent like this, where the point touch the graph, that straight line touch the graph, the particular point I want to measure the rate of reaction. Then the rate of reaction said to be what? Instantaneous rate, or INS is equal to change in concentration of product dou P by dou T is equal to x2 minus x1 by t2 minus t1. Okay na? But here slope what we got it? Positive slope we got it. This is information regarding average rate of reaction as well as instantaneous rate of reaction. Average rate means the rate we measure for period of time. Instantaneous rate of reaction means the rate we measure for a point of time. Thank you.